Well, so this time instead of like learning, I'm more of like trying to visualize whatever things that I've learned on system design on TinyURL. So I will just like get started with the requirements and non-functional requirements. So requirements is that given a URL, I want to have a system that is able to convert the URL into TinyURL. For example, tiny slash say 7 characters. The characters can be A, B, can be numeric. It can also be alphabets, but it's uppercase. So it is a list of say no, it is a combination of a random alphanumeric characters, and then into like 7 characters. And whenever the users have generated the link, if I try to access this link, I will then be redirected back to the actual URL that I am storing it into. So this is on our functional requirement side. So non-functional requirements, it has to be say consistent. So the reason it has to be consistent is that say for example, if I generate one link of 7 characters, I do not want other people to generate different links but become the same tiny URL. Then it will mess up, because next time when I try to fetch the URL by TinyURL, I will end up fetching like other people's link. So I want it to be consistent, so there will be no say data corruption occurs in my system. Second thing, it has to be scalable. So this system has to be able to say handle like billions or millions of users active at the same time, or in 1 year. So I do not have a specific number in this case, but the key is it has to be scalable to a lot of users accessing the system at the same time. Yeah. So highly available. After I generated like say a specific tiny URL, I want it to be able to be available like 24/7. Yeah, because on 99% of the time, because with this tiny URL, sometimes it can be links that I want to access like at certain point of time. So when I just remember this tiny URL, I want to be able to access my link anytime when needed. I don't want it to be suddenly system down and then I'm not able to access what I want. Well, so I guess with these three non-functional requirements, we can then start design our system. So the first thing, I will go through algorithms first, because this is again quite interesting, and this is a core in which we can choose our approach from. So the first approach that I'm going through will be this algorithm called MD5. So MD5 algorithm, it will take a string as a parameter, which in our case is a long URL, and it will generate 32 bytes or 32 characters of combinations of a random string. So with this, we can then say, for example, we can take 7 characters from the first 7 say bytes, then convert it into a tiny URL. So this can then be the key for my tiny URL that have been generated. So we can access the say pros and cons of this algorithm first. So first of all, the pros, I think it will be say straightforward. I'm not sure if straightforward can be one pros, but because you see like for example, I algorithmic wise, I can just generate like 7 characters, and I will check generate characters, and then I will check if conflicts occur or collision occur, like conflicts, or because it is already exists in the system, so I cannot use this link. If so, then I will either use like generate I'll either choose like say one window behind, choose the second character until the 8 characters, which is combination is also 7 characters, and then I will attempt to call the database again. So it's sort of like a more, say, a simple kind of approach where I don't need to maintain any other things. The algorithm itself is like stateless. Any string, I can just put it in, and then I can expect to have like a general or random strings that most likely will not conflict, but it will also happen. It's not impossible to happen. So the cons is, again, conflict will be the cons. It's quite obvious that, like even two different links, they have the same 7 beginning bytes who are the same, then the remaining only different. So we cannot avoid the situations where we can like confirm that there will be no duplication of the random string happened or occur. Well, so this is like a pros and cons of ND5 algorithms. And with this algorithm, actually we can also design a system that uses this. But I guess we can just skip this, and we explore further into another algorithm, which is called the base 62 algorithm. So base 62 algorithm, it takes in number as a parameter. So all this actually I learned from YouTube. Maybe after this I'll try if I can find the link attached in nearby. I think I can find it also, like this system design TinyURL. Yeah, so this person's it is very good explanations on the algorithms and also the infrastructure components that can help achieve the non-functional requirements that we mentioned just now. So base 62, it will then take in, say, a number, and it will convert the number into a base 62 encoded characters. So and it is sequential. For example, if I this is just an example for more like exact algorithm, maybe we can explore further by referring to, say, tables or ASCII table, say, that can help us to understand more about this. So for example, if I pass in 0, then every time if we pass in 0, then it will always convert into, say, number 0. If I put 1, then it will be a number 1, so on and so forth. So I can then say I prepend all 0 at the front and make it 7 characters. So this can become one TinyURL slot, and then 1, it can also like prepend 6 characters also at the front. Then it will also be another unique kind of 7 characters. So this can happen until every slot we can have alphanumeric characters. We can have 0 to 9. We can have A to Z. We can also have big A to big Z. Yep, and these are the combinations that we can use for every single slot. So now we have 7 slots, right? So with these 7 slots, we can assume that every combinations, it can happen in every slot. So which in a way, we can estimate how many or say combination of characters we can use. Say I think it will be like 62 possibilities times power of 7. Yeah, because every slot we know that we can insert like 0 until Z at the back. So it is sequential. First of all, we can do something like, say, we can assume like this is a storage or the database that we can use. So it is like 0, 1, 2 until like 62 power 7, and every single one is a slot for us to add in like this long URL. Right? I refer to this as a key value pair. This key refers to that long URL. So again, we can access roughly with this algorithm what is the pros and what is the cons. So the pros, definitely it is no conflict. We always know that if we pass a number, it will then definitely it will translate into something more unique, because the number we will not repeat whenever we generate a new say characters. Second thing, how about its cons? Its cons is definitely we need to maintain. It is with state, so we need to maintain the counter of how many what is the number that we are currently in. So it is not like we cannot resolve this. You see, like as long as we have something a place to keep track of these states, then it will be good to go already. So which in a way, by comparing the algorithms, MD5 algorithms and the base62 algorithms, we can actually say that base62 is a more suitable one, because we know that as long as we maintain the state, we have no worries about conflicts within the database. So I don't need to do like database lookup every time when I generate a new URL. On another hand, with if we use MD5 algorithm, we need to have another set of algorithm that is able to detect the conflicts and resolve the conflicts. So we don't want to keep like looping and especially until like towards the end, because the MD5 hash is like there's no specific order to what are the numbers that will be generated, or what are the characters that will be generated. So towards the end of the storage that we have among the 7 characters, we will hit conflicts more and more frequently until the end. It will be extremely slow. Say for example the last unique characters that will be generated, because there's only one slot remaining, and there are a whole lot of other slots that have been taken out by the rest of the TinyURL. So we can also conclude that okay, now we will go for the base62 approach. So base62 requirement is we want to maintain the counter in one place, and then the rest will be quite similar. So now let's go forward and try to do some design of our infrastructure components according to this base62 algorithm. So first of all, guess we can go for client. So this is client, and definitely they'll go through like say a proxy server, say NGX or other server that can redirect the request into a service. So we have one service called base62 service. They contain the algorithm that we want to so we want to put in this that's able to generate like a convert decimal point like a base 10 number into a base62 encoded characters. So we will have this service called base62 service. And this specific algorithm, it can actually be scaled by increasing the number of services. So it can be like, for example, with a load balancer, we call this as a load balancer. I think it will be better instead of nginx or anything. Then the request, it can then be like distributed among the base62 services. So they can be in other like in multiple locations according to say we have say if we support like countries in Southeast Asia, then we can have one server in Malaysia, another in other countries. So whenever the request come in, we can then specify that okay, so which server is fastest at the moment and it is not having a heavy traffic, then we can select that for processing the algorithms. But in a way, because this is like quite a simple service, so maybe you can also think of other approaches. But for now, I think this single service is sufficient for us to do the processing of the decimal numbers. So this service, it has to have access to two things. So one is definitely the database. So database to keep the record, where the record will be, we have say ID. We also have short URL. We call this a short, and we have a long URL. And next we have say other metadata like timestamp and other things that we want to keep track of. So and we have like every time say for example the ID is 0, 1, 2, then we have like records that we anticipated because we are using decimal places, so it will then be like sequentially added in. It is one possibility. It can also be like in non-sequential order, but we can explore that further later on. So now we have this set of records, and we know that operational wise, likely we can also have another service. So in here I written as services, but in actual one already we can actually put the services together if they are not like very resource intensive. But we can also separate into multiple services, easier for scaling by services. So another service, say it will be like lookup service. So this lookup service is in charge of getting the data from the database. So it will also have access to our database for querying records. So this lookup service, it then every time the user, maybe they'll fill in like short URL, and then the system will go ahead and find the database and identify the records that fulfills the short URL, and then provided with the long URL and other details. So why we need to emphasize this? Because now we know that every time we want to do query, the query will be only one single row. We will not have like situations where we want to query a range of IDs or a range of time. So with this being said, we can actually decide what type of database we want to use, which in our case I will choose RDB and MS, so relational database, for example like MySQL or PostgreSQL or other SQL databases. So the reason I would choose a relational database over NoSQL is because over like document or columnar databases is because RDMS is good in keeping data row by row, right? That's what it does, and it can also the fetching of records by row is very fast. So I can then say for example I index the ID. I don't even need to index. I guess I can just select the specific ID records. So RDBMS in this case is a suitable choice, in my opinion, for implementing or for designing such services. Okay, so that is how we can do the query. So coming back to where we are now we still lack of one item, which is the counter. So in terms of performance, I mean let's have a look at how we can manage this counter. For example, say if I use a cache to maintain the counter, like say Redis. I think in this case I would say Redis is probably a good choice because it is a real-time database, and if I have like one counter here and I can keep referring to this specific key in order to get the counts. I can also have like for example a range of keys that provides a range of counts if I want to further scale up the system. I think Redis should be a doable choice. I guess for example like a count 0 to 1000 is one key, and then 1001 to 2000 it will be another key. So I can then, for example, if I have this service 1, service 2 and service 3, they can be independent. So say service 1, I will refer to the Redis 0 to 1000. So I assign this to 0 to 1000, and then service 2 I assign to 1001 and until 2000, and so on and so forth. So by doing this, we can see that each service that we deploy does not have restriction with each other, so it can have a set of counter that going on in parallel with other services. So there's no dependency like everyone should access to a same count. Then that counter will definitely be a bottleneck in my opinion. No matter where we store it, like even in a very fast say place, like Redis or other real-time databases. So now Redis is one choice, but I also want to mention this thing called Zookeeper, because Zookeeper is what have been recommended by this the YouTube just now that I've shown. So Zookeeper is like a leader of a set of nodes that keep. No, I'm just saying, I'm not exactly sure what it does, but apparently it is able to steer and maintain the counters or from a cluster, like efficiently, like this way this one I really need to do more research on this. I realize that I am not very understand about that, but basically all this service can then communicate with this Zookeeper, and Zookeeper will have like buckets of counts, a range of counts, similar to what I mentioned in Redis. So whenever there a new service they query, then Zookeeper will assign this set of configuration to that services, and then it will assign to the next services and the next, so on and so forth. And if one service has exhausted all the counts that have been provided to it, then you can then request from Zookeeper again, and Zookeeper will provide you with another set of counts, and these counts can then be maintained like independently by each service. So for example, again coming back to Redis, you can actually use Redis with enable the persistence to keep maintain the count within each services. So just like I mentioned about maintain in the disk, so maybe I can also mention this here. So it's a persistent real-time database. Whenever the Redis down, there will be a way for us to back it up by using a disk, and also using another thing called WAL, but that part of it will be more internal to Redis, so I think we will not go through that in this system design. So that solves the problem where we need to maintain a count of multiple services in parallel. So this way is actually very efficient for us to generate a short URL based on the long URL assigned. So query wise also, it is worth to note that if we hit like performance issue where the query of data from our database, relational database, starts to be significantly slower, then we can always add say our cache in between, like again Redis cache, where it will be in the I forgot the terms already, but basically it will coming as queue. So for example, the Redis has a finite amount of slots. Say I just roughly conceptualize it. Say you can only have 5 records at one time. Then the lookup service, it will find out whether this Redis is it has the data that I want. If yes, then I will fetch the data, and the data will be also like pushed into back into the Redis, or we can update the timestamp also, so that the Redis it will discard whenever it reach a maximum cap, it will then discard the oldest data. They are not more being accessed by the lookup service. On another hand, we can also do something like the most frequently accessed URL, short URL, will be remain in the Redis, while the least frequent one will be discarded when the Redis hit its capacity limit. That can also be done. So in this case, the Redis cache can be a good solution in between the lookup service and our databases for like a better speed, or performance. And then lastly, how if we want to introduce like things like monitoring service for the entire system? I guess this is also another part that I'm not that familiar with. Maybe we can explore further on, say, the way to convert this, either whenever there is a request being done here, or there's any errors, it will then be come an event either into like a Kafka stream or something, And then at this point, maybe we can put as Spark Jobs, which is another thing that I'm not very familiar with. And moving forward, we have like another visualization service here. Okay, so that basically wraps up like what I remember or what I have learned on a TinyURL service. Moving forward, I will also try with other system designs of like other services or other platforms as far as I know or I learned from YouTube or other sources. Guess that's all for the sharing today. Have to go for another meeting. So yeah, that's all. Thanks.